Ronald,
Yeah,
I think we can start.
I would also think we can start, and yeah, so it's your your time.
Okay, thank you. Pozdrav svima. Ja sam Perica Rimac iz tvrtke Belmet iz Zagreba, koja je suorganizator ovog webinara i želim vam svima da uživate u prezentaciji našeg partnera tvrtke leXsolar. Pozdrav svima iz Hrvatske, Bosne i Hercegovine, gospodin Petrović iz Srbije, tu koliko vidim. Sad, ako ima neko iz Crne Gore, nek me ispravi, nadam se da ima, tako da evo, pozdrav svima. Predstavit ćemo teme iz obnovljivih izvora energije, energija vjetra, termalna energija i hidroenergija. Što se tiče potvrda o sudjelovanju na webinaru, u chatu sam napisao već svoj mail perica.rimac@belme97.hr, pa vas molim na taj isti pošaljite svoje podatke, ime, prezime, ustanovu, školu u kojoj radite, da možete dobiti potvrdu o sudjelovanju koja vam može pomoći u napredovanju u bilo čemu, tako, ako vam to što znači. Evo. I to je to što se mene tiče, to je samo jedan, da vas pozdravim i tako, evo, gospodin Ronald može krenuti u webinar, zato smo se tu i okupili. Mr. Ronald, you can proceed with the webinar if you want.
Okay, so hello to everyone from me, from Dresden. My name is Ronald Hübner. I'm product developer here at leXsolar, and I want to give you another presentation on our products. So let me show you our little overview about all our products. So I hope you can all see now my presentation. And please mute yourself, guys.
Zamolio bih samo da se ugase zvučnici, mikrofon samo da, jer čuje se nekakav zvuk u pozadini, pa evo, ako nije problem.
Let's see, we have all our products, you can see here. leXsolar usually is doing on all experimentation kits on all fields of renewable energies. I think last time you already seen us presentation how photovoltaics work. I will show you quick. We did an overview how does a solar cell work, or and what is inside our products for solar energy. Mr. Kushinkowski last time told you about the smart grid technology. It means a net structure for electrical energy, which distributes electrical energy through the whole net structure in a country. That means from the renewable energies and also from the fossil fuel energy power plants, and all mixed together into it all has to be mixed together into a grid structure, and that all has to be managed by a smart grid, by computer supported grid structure. You've already seen that, and of course last time was the leXsolar e-mobility. How does batteries work, how does energy saving work? We have in our e-mobility experimentation kit different capacitor modules, different accumulator modules, which you can investigate and see the charging and the discharging process, and you can compare them. Yeah, and so I don't want to repeat myself too much. So yeah, I obviously won't do a presentation on these topics again. Today, as you heard, I want to focus especially on the wind technology, on the thermal energy technology, and on the hydropower technology, which of course we also have experimentation kits about. Let's have a quick look. How does the wind energy, how does the renewable technology work? Yeah, we have some kind of a wind turbine, and we have all different kinds of wind turbines which we can investigate. And yeah, wind energy is a great field in Europe. We have great possibilities, especially with the onshore wind and also with the offshore wind technologies. It's a huge market and it's increasing furthermore. And this means that there are many jobs inside this wind technology, and so we have to train our students at the university, at the schools, on this specific technology. And yeah, with our experimentation kit, we want to give an overview for the students on how the whole technology is working. Let me show you what's inside our leXsolar Wind Professional Experimentation Kit. Again, we have everything inside one suitcase, and we want you to be able to open the case and start right again with the experimentations. Yeah, we are going with the wind technology, we are going from really the fundamentals. You have some basic experiments integrated, which you can investigate Ohm's law and how does the electric circuit works in general, but of course we focus on to the wind technology. Here I have a little overview over all components, but I think yeah, it's better if I show it to you in real. So I will stop my presentation now and switch the cameras here onto the experimentation kit. Here you see it. So let's see. So this is our experimentation kits. Here I am. At first I want to show you, this is of course the suitcase, and as always, if you open up our suitcases, you have all our products displayed here. You have a layout diagram. I can hold you into the camera where all you see in the experimentation kit in one picture, and yeah, always good for the students so they can clean up their mess. So here we have it all, everything in one case. You just need some power. And yeah, for start, I want to show you how easy it is to set up an experiment, and how easy it is to experiment with our leXsolar products. So everything I will show you now is taken from this case. And yeah, let's start with our main parts of the experimentation. This is a leXsolar base unit. leXsolar base unit, you see, has some conducting strips on the back, and all leXsolar modules can just plug in to this base unit. This is the principle of all our products. You can just take all modules inside the case and plug them onto the base unit. This is how we build up our experiments. We have these blue modules and just drag and drop them onto the base unit. Also note, these are rather stable and good material modules. You can just let them fall. Nothing will happen. They are quite student resistant and long living. So let's start with an experiment for you, and you can see how it will work. At first, this is of course the wind theme, so we need some wind. In our experiments, we always use this wind machine. The wind machine is also present in other experimentation kits, for instance, the leXsolar Smart Grid. You may know it from there. But of course, in the Smart Grid, we can't go to the details of the wind technology as we can here. So for start, I want to create some wind. I can just
Mr.
plug
Roland,
in my
Mr. Roland, I must say something. I'm on the big screen. Am I and not you? So can you check this, please?
Sometimes there's a bug with Teams. If my screen is
Now it's
too
everything
small,
okay.
you can hover over my screen, and then you have three little dots in the left corner, and you can say spotlight or mark my camera, and then I will appear bigger.
Okay, now is everything okay? Okay, you can proceed. Sorry.
Yeah. It's a known bug from Teams. I don't know why this happens sometimes. Okay, so let's move on. So again, this was the wind machine, and now I will set up an experiment. And for start, okay, I need wind, and I need some power to have my wind machine running. For the power, we have always these power modules. You may know them. They work with standard 230 volts, and they convert the voltage down, and then you can regulate it from 1 to 12 volts input onto this wind machine. And of course, you can regulate the wind speed by the voltage. Means the wind machine generates more wind if I power it with 12 volts than with 6 volts, for instance. And let me show you. We will power the wind machine with the power module. You see, it's all, I'm taking it out of the box, and I can start right away. Of course, I'm a little advanced, and I know what I'm doing. If you're new to leXsolar products, it takes some time to adjust, but then it's just, take it out and go on with the experiments. And for now, we want to do a wind experiment. I have a wind tower here, and I can set up my own rotor blades, as you will see. So this is the wind tower, and now I can set up my own rotor, my own wind rotor. I will show you. I have a little kit of different materials. I have these triangle-shaped rotor blades. I will hold it into the camera. The triangle shaped, and then for comparison I have this classical shaped rotor, so I can build up a classical windmill. I will show you in a moment what this means. At first, I want to set up a regular 3-blade rotor. I can just take my rotor blades and build up my own rotor with the kit. So I have a standard shaped rotor blade, 3 blades, with a pitch angle of 25 degrees, and I can just plug it onto my wind tower. And if I run my wind stream now, obviously it will rotate and start to generate electricity. I can show you that it will generate electricity by installing this small motor module, which works as a consumer. So now if I'm starting the wind machine and I'm powering up the wind, the wind machine starts generating wind, and come on. Okay. Just move it a bit. So I will show you. So the wind machine is blowing the wind into the direction of the turbine. The turbine is getting the energy of the wind. The kinetic energy is generating power, and in the end my consumer here is working. So this is a small setup experiment built up in a minute if you want to see. This is how the experiments generally are working. We have our wind machine. I can now alter the wind speed. I can alter what kind of turbine, of rotor blade I'm taking, and in the end I see, okay, there is electricity generated. This is it's an experiment for starters, but as I told you, this is the professional experimentation kit. So obviously there has to be something a little more. To show you now. To show you now some different experiments. I want to build up another rotor. I have here now these classical shaped rotor blades, and I can build up a second rotor with 4 blades, like a classical windmill from the Middle Ages you want to, and I can just see what happens if I use this rotor instead of my optimized rotor blade, and I can see what will happen again. This time my consumer is not really starting, is having problems to start, is not spinning that well. And so I can see a difference when I'm doing little comparison experiments. So now I want to go to the detail. I want to know what blade shape and what rotor is the optimal rotor for wind turbine, and why are all wind turbines out in the field? You see them, they always have this form. They always have the triangle shaped blades. They always have a pitch angle of 25 degrees, so they are optimized. Why is it so? So now this is what's all about inside the wind professional kit. I want to know why are the wind turbines out in the field built that way, and this is what I want to show you now. So everything I can do, every time I do an experiment with this kit, I will show you I can alter exactly one factor. Yeah, I can always I can alter the wind speed, I can alter the shape of the blades, I can alter the pitch angle of the blades, I can alter how the wind has, in what angle the wind turbine is standing in my airstream. And by always altering one parameter, and then I can measure the voltage and the current which is given me by my wind turbine. I have this AV module which works like a digital multimeter. So with this and with a potentiometer, classical potentiometer, I can investigate. I can investigate an UI curve from current to voltage, and with this I can calculate the power which is given me by the different wind turbines I will build up for you. And with this I'm calculating the power and always entering one parameter, and by this I can optimize my my rotor and my whole wind turbine. So let's see. I told you I can measure the wind speed, and the wind speed is depending on which power I'm giving onto the wind machine. I can measure the wind speed at first with my aerometer, which is also integrated in the professional system. I can just plug it in here and measure the wind speed. So I know the wind speed. I know what power is given me by the wind machine. Then I can calculate, of course, the power which is given me by the turbine. So I have a factor of which I can relate to the power I give into the system, and I can see what comes out of the system. So now I know the wind speed. I know the angle my turbine is set up inside the wind stream. Of course, if I blew these optimized blades from the side, nothing will happen because they always have to stand inside my wind stream. So now we can alter the wind speed and the angle of the wind turbine inside the wind stream. So this is another parameter. Now I can go there and alter the number of the blades. Yeah, I've told you I built up these rotors. I can also, of course, rip them apart. And I could see what happens if I, for instance, use a two-blade. When I only use two blades. So I only use two blades now. Put them inside onto my wind turbine, and again I can see what voltage, what current this turbine now gives me. And you see at lower wind speeds a two-blade turbine won't even start. At higher wind speed it will also start, okay, and it will generate a certain amount of power. So again, I could also do this with the classical shape of blades. Also I can alter the angle of the blade. me see where is it? Yeah. The angle, how the blades are inside the wind stream. You see, I can, for instance, take a 90 degrees angle. So with this, the wind will only blow through the blades, and nothing will happen. And by this, you see, I'm always altering one parameter, and every time I take the voltage and the current, and I'm optimizing my wind turbine every time. And last but not least, I could also change the angle or from horizontal wind turbine to a vertical turbine. We also have a Sabonus rotor in here, which has a vertical turbine, a vertical axis. And I also could investigate what power is given me with the Sabonus rotor, and what positives and what negatives has this axis to the horizontal axis. So you see, you can alter the wind speed, the axis, the blade shape, the pitch angle of the blades, the angle of the turbine to the wind stream, and every time calculating the power, every time altering with the potentiometer. I can do a UI curve, and every time calculating power and get the optimal, or investigate why are these wind turbines you see out in the field with the triangle shaped blades with the 25 degrees pitch angle, why are these the best? And that's what we want to do with the wind experimentation kit. And yeah, I want again just to show you this Sabonus rotor, and I can always, you see, it's just plug in, plug out. I can see this is 90 degrees, and oh, this is very loud. And sorry guys. Someone please turn off.
Molio bi samo nekoga da ugasi mikrofon, molim vas.
Yeah. So let's move on. So this was a small demonstration on our wind experimentation system. I think it's one of our most straightforward systems because it's very easy, very simple to build up, very fast to build up. You can work in groups with the students, give them different tasks on investigating how the power is working, and yeah, I think this was the first demonstration for today, and yeah, time is running. I will proceed with the next presentation in a moment. So for now, let's change my camera. So here I am again. So this was my first presentation on wind technology, and for the second part of the product presentation, I want to give you an overview for thermal energy. Also, I think it's a very cool subject. It's not that big of a deal sometimes in schools, but yeah, it's a very bright field in the industry. I sense that mostly all students know about solar energy, and they know it's a solar panel, it does something, solar sun to electricity, okay, but they're not aware that big of the thermal energy, and yeah, we want to change that. We want to teach the students what you can do with the heat of the sun and not only with the light. You see here there are different kinds of solar thermal power plants, and you see we have these flat collectors onto the roof sometimes, and you have the concentrated solar thermal energy, and of course we want to teach everything or the basics with our experimentation kit. And again, I don't. This is everything what is included inside our experimentation kit. But yeah, I don't want to bring up the boring presentation when I can show it to you in real life, and that's what I'm going to do now. Again, if you want to have an overview of all our products, you can go, for instance, on YouTube. There are product videos on every product where you have a little experiment, and also this components charts, and of course you can ask all our distributors about what's inside our products. So without further ado, I will proceed with leXsolar thermal energy. So again, everything's inside this case. As always, we have opened the case. We have a little overview chart on what's inside the case and where does it belong. And yeah, let's see what we can do with this experimentation kit. You see here we have a flat collector. I will show you an experiment with a flat collector today. And yeah, but first we want to see some basic experiments with the leXsolar thermal energy kit. For starters, we have again a leXsolar base unit. This time it's a bit smaller for this experimentation kit. And of course we need some sunlight. We have this 100-watt red light bulb here for sunlight. And with this we want to do again a little basic experiment on what is thermal energy about. We have, you already know it's a bit different than the wind technology now. We're going into a different field with different modules. For start, I want to show you this module. This is a black and white module. It's a copper plate which is painted with the white side and with the black side. And inside here is a thermal module which we can use to investigate the temperature of the module. So I will now place my module in front of my lamp. I have a digital multimeter, and yeah, I need a watch so I can start my experiment. I hope you can see it. Of course it's mirrored, but I can now light up my white side of the absorber module, and I can investigate. I take a watch or something, and every minute or every 30 seconds I take the temperature, and so I can do a temperature time correlated graph. And after this, I wait a little and let the absorber module cool down, and I just turn it around if it's cooled down and let it shine onto the black side, and then I again see how the temperature is rising up and how fast it goes. Yeah, every 30 seconds I take the temperature and then I have a graph. This is, of course, here the black side is heating up more faster than the white side. So I know now that obviously a black surface is absorbing more and faster the heat energy of the light. So with that knowledge, I can now investigate. I now know why all solar thermal collectors are black. And of course, our collector is also black. This is the leXsolar solar collector, flat collector. And again, I can, you see, I just plug in, plug out my modules. And now, let's adjust a bit the camera angle. So now I want to investigate how does the heat, the temperature is flowing if I build up a thermal energy system onto my roof or something, as you've seen before. So I need water circulation. For water circulation, we have a water reservoir and a water pump in here. I can set it up. I will just plug in the back my, hope you see it, yeah, my water pump, my water reservoir here. I will add some water now. I need some hoses for circulation. So again, this is all inside the experimentation kit. So I just take it out and do my experiments. Of course, again, I know what I'm doing, and doing it on the first time may be a bit difficult, but yeah, I think also your students will figure it out. So I have a water circulation set up. I will show you in detail. I will add some water into my water reservoir. I'm again running the water pump with my power module. This is the power module. And again, I can alter the speed of the pump or the power of the pump by altering the power module, but I won't do it in this demonstration. And now you see, setting up the power module. So, you see now, my water reservoir is emptying, the water is flowing inside my system. I will add some more water. Come on, some more. So I hope you can see it now. Let's switch off. So now I pumped all the water into my heat circulation system. And now I want to investigate where is the temperature and what temperature do I have inside my whole system. So I can measure the temperature. At first I'm heating up the solar collector. I'm starting my pump. So now this is heated up. Water circulates through the collector pipes. Maybe I can show it again in detail. So you see here, this is a copper pipe which has the black background, and as we've seen, black is very good for absorbing the heat. So now I can investigate with the thermometer what level of heat I have back in here inside my, here I have a thermometer. What temperature do I have back in here inside my water reservoir? Turn it off so you can understand me more. So this is temperature 1 back in here inside the reservoir. We have a second temperature sensor inside our collector module. I can just measure the temperature inside the collector by using our base unit here on the bottom. There's a conductive plate here on the bottom, so I can get a hold of the temperature inside the collector. So you see, I have 33 degrees inside the collector, and I think 28 or something back inside my water reservoir. So that's the difference. And last but not least, I can measure the temperature with another temperature sensor and another digital multimeter anywhere in the system. So I have two possibilities for static temperature measuring management, and I have another multimeter with this small temperature sensor. I can investigate now on every time maybe on the flat on the surface of the flat collector. I can now build in another heat exchanging module. I have another hose here with me. And so this is a basic water circulation, which you can install maybe onto your roof here. And you use the heat of the sun to heat up a water reservoir. And this hot water you can use in your house. But sometimes you need a heat exchanging module for other reasons. And of course, with the whole setup, we want to investigate the exchange of heat inside different materials. So now what I want to show you is a little add-on within the experimentation kit. This is a heat exchanging module. You see again here inside is a copper pipe, and I can integrate this copper pipe now within the water circulation. So I can plug out the hose here. The water will be flowing out. I can add this here and integrate it inside my water circulation. So now the water is flowing from the flat collector inside my water reservoir, inside my heat exchanging module. Note this is empty. You can now fill the heat exchanging module with water and measure the temperature inside and see how does the heat exchange work. You also could fill it with oil or with sand or something else. You want to show your students how the heat exchanging process works on different materials. This is a very cool experiment, and as I told you, now you can investigate or compare this flat collector unit to concentrated solar power. You can also do the same experiments with the flat collector and with the concentrated solar power. Let's move it a bit in the back, everything. And I want to show you, we have this absorber pipe module, which now will replace the flat collector in theory, because I want to show you, I will show you how it works in dry. So I have this parabolic mirror, and I will place it in front of my absorber pipe, and I can now shine my mirror, my parabolic mirror with the sun. The parabolic mirror concentrates the heat energy onto the absorber pipe, and obviously I could now integrate my whole water circulation system onto the pipe here and run a water cycle through the absorber pipe, and so I can investigate the difference between the flat collector and the concentrated solar power. Yeah. So this was the second short demonstration of our products. This is a thermal energy, and maybe I show you pictures a bit again. There are YouTube videos on everything. Oh. So, you see, this time the build-up of the experimentations was a bit more complicated, and I already prepared something that I can do it that fast. So a little preparation time is needed for this, but I hope I could give you a little insight of the thermal energy experimentation kit. For me, it's one of my favorites because I like the topic, and again, you see here all the different components. I've shown you 20% of the components. Okay, we have another basic experiments on heat absorption with the lens and a small absorbing module. We have a Peltier module inside here, so you can investigate how the heat can be used to generate electricity again. We have a paraffin heat exchanging module inside here. We have a cooling aggregate. We have this isolation here for the heat exchanging module, so you can investigate isolated and non-isolated systems. It takes some time to set up, but the experiments in the end are very cool, very unique. I don't think with this complexity and this size you have very few products in the market. So take a look inside. This is a very cool topic. And for the last topic of today, and because everything's wet here already, I want to show you the leXsolar hydropower system. leXsolar hydropower system, again, a unique one. I have to admit, we have less experiments in here, but the experiments show a lot. And yeah, that's why I wanted to show you this experimentation kit at last. Of course, we need some water in for running the experiments. Yeah, hydropower. But yeah, I'm in the office, so I have to show it to you dry. Hydropower in Europe's very efficient field for power. Yeah, the hydropower generally is or historically is very good, investigated, very yeah, very efficient already. And yeah, we want to show the students how does it worked historically and how does it work now. Yeah, big power plants all over Europe. But I have to say the water power or the hydropower in Europe is opted out more or less because of environmental restrictions. Yeah, you can't alter the shape of the rivers or add another water storage, big lakes or something, because it's already opted out, and you have also these big environmental issues can happen if you install big hydroelectric power plants. But nonetheless, the technology itself is very efficient, and yeah, how we want to show the students how does the hydropower work. Again, we have three different, you see here our main module, the turbine module. We have three different turbines. We have a water wheel, we have a cross-flow turbine, and we have a Pelton turbine. And yeah, again, we have here a little overview about everything. We have some consumer modules again in here to show you, yeah, there's really electricity produced. We have two different grand sets of experiments. First is the general water flow, and the second is investigating the turbines. So now I have some minutes left, and yeah, let me pack a bit, and then I will show you the water turbines. So, here I am again. And here we are again with the experimentation kit. Yeah. So again, everything's in our suitcase. Let's open up. Again, it's a bit different. I'm already showed you two different experimentation kits, and now we have the third. We have here the possibility of doing water flow experiments. Yeah, I will show it to you. So we have our water flow boxes in here. Check it out. These boxes are for the water flow experiments, which can be done everywhere if you have some high ground. I have three different hoses. With a certain diameter. See? I have three different hoses with three different diameters, and I can now build up a small water flow experiment. Let's use this one. I will set up my top box. Yeah, this is my water reservoir. I can just plug in my hose in here, fill the water reservoir with water, place it onto the high ground, and now I can open up the river or something and measure what time it takes for a decent amount of water to flow down here, and what amount of water in what time is flowing through my different hoses with the different diameters. And I can calculate the energy from the high to the bottom, and I can calculate what energy or how much water is flowing through the different diameters, and what is better, a high amount of small diameter hoses or one big hose. What is better for the water flow, for instance. This is general water flowing experiments. I can alter a bit. I can give the children's or the students different tasks on which how high does my water reservoir is, how much energy is in there, how much potential and kinetic energy I can use with the different heights of the water storage up here. And this is the first set of experiments. And for the second one, the basics one here, for the second one I want to show you the water turbine in detail. So let's see our water turbine module. Again, we have a small base unit here, and so this is the water turbine module. You see in here, inside here, I will place my water turbine, my water wheel. On the back I have magnets. These magnets will spin around as the water is flowing inside my water turbine. So I have three different modules, three different water turbines. I have this classic water wheel. I have a cross-flow turbine, and I have a Pelton turbine, which is the best in efficiency. And I can place my turbine in here inside the housing. So come on. Now, so I can place it inside house. And now, if I would plug in my in here, the turbine would be running, and the magnets on the back are spinning. That's how our water turbine works. And in the back of these magnets, I will place my induction plate. Yeah, see, copper for inducing the voltage. So if the water wheel is spinning, the magnets are spinning and inducing electrical energy in the back. And this is how I can generate electricity by inducing, or this is how generally a hydropower plant works. Yeah, the water is spinning a wheel, and the wheel is spinning magnets, and so I induce the voltage. And I think with the hydropower system, you can, or the students can investigate it directly. This is why I like it so much. So I can place again the module onto my base unit. I have the possibility to alter the angle which the water is running onto my turbine. Yeah, I have an upper angle and a lower angle, and I can alter where the water flow is going onto my water wheel. Of course, this is the layout of the water, and I have measuring device for the water flow I can place on top. So basically this works the following. I need water from a water tap here, because I need a certain pressure of water. I need 4 bar at minimum for running this experiments. I can place my water turbine here with another hose, which is also inside of here, onto the water tap, and then create a whole circulation. Well, it's rather big for the camera, and I can plug it inside a water tap and run all experiments with water from the water tap. Of course, I can do it now in my office, but again, there are some videos on YouTube which, if you're interested in, you can watch, of course. Okay, this was my last presentation, and I hope you could enjoy our products. And yeah, if you have questions now, you can ask me. This from me for now. Periak, you wanna say something?
Okay, thank you, Ronald. It was a great presentation, I think so. I think everybody will agree with me. Prije svega ja se opet još jednom zahvaljujem svim sudionicima webinara. Nadam se da vam je bilo zanimljivo, da ste nešto naučili novo. Ja jesam, tako da opet ponavljam, znači moj mail imate u chatu za bilo koga. S obzirom da imamo dosta učesnika iz Bosne i Hercegovine koji nisu sudjelovali do sada, evo da ponovim, znači za potvrde o sudjelovanju na webinaru, da dobijete nekakav certifikat, potvrdu, javite se meni na mail pa ćemo to riješiti samo znači sa podacima koja ste ustanova, škola i tako dalje. Što se tiče opreme leXsolar, poslao sam i katalog, tako da možete pogledati što se to događa. To je 10 različitih setova za 10 različitih područja. Ovo je drugi webinar koji smo imali. Prvi imate na našoj web stranici snimljen. Imali smo fotonapon, smart grid i e-mobilnost, tako da dosta zanimljive teme, možete pogledati koga zanima. A što se tiče bilo čega, pitanja, informacija, cijena, isto imate moj mail, slobodno kontaktirate, imate što se tiče prezentacije u bilo kojoj školi, znači mi imamo setove demonstracijske u firmi, tako da nije problem bilo di doći, prezentirati, pokazati, ostaviti čak na tjedan, 10 dana da se profesori igraju, učenici i to radimo, tako da evo, što se nas tiče, to je to. Ako imate kako pitanje neko, evo slobodno sada dok je gospodin Ronald tu, pa evo, ako nešto se sjetite poslije, slobodno mene kontaktirajte i to je to. Evo, što se mene tiče, hvala još jednom i želim vam ugodan dan i to je to. I can translate you something, but everybody says that you have a great webinar. I agree with them. Yeah. Okay.
Okay, then I want to thank you guys. Yeah, I think maybe we see again. I think we have other products.
Yeah, you have 4 more.
Yeah, we have 4 more, which are, I think, bioenergy, biofuel, H2, and no, 3.
I believe you have 10 topics.
Yeah, maybe the card, but the card is currently not in store, so
Okay.
we leave that out. But of course, bioenergy, biofuel, and H2, which is H2 we have, or we will have some new products. Michael already sent out a newsletter, and maybe in a couple of months I can show the new products already. And yeah, of course, bioenergy is one of my babies, which I was directly involved with the developing process. So I would look further to show you this, but it takes time to prepare for this because I have to set up some plans. But yeah, I'm looking forward to it. I hope you enjoyed my presentation. I always try to focus on the practical part and not so much on the presentation. Yeah, again, if you have questions, you can always ask us. And yeah, also I recommend again the YouTube videos. They are 5 to 10 minutes on every product in English. And yeah. Okay, this was it from me. I hope you have a great day. And yeah, goodbye from Dresden.
Okay. Thank you one more time, and bye. See you.
Goodbye.
Bye.
Bye.